There's a lot of work in AI where you can say, oh, our AI has succeeded in parsing this document. Our AI has succeeded in reading this article. That's not the thing which is actually tied to value. And it's environments where the AI can really identify this and go and get that value back.
Welcome to Agentic Thinkers, the series where we talk with the people actually building agentic AI. Not the hype, not the headlines, but the real systems, teams and ideas creating measurable value in the world right now. I'm your host, Matt Elsey, and in each episode we'll dive deep with founders, CTOs and enterprise leaders who are shaping the next wave of intelligent systems. Agents that think, act and deliver outcomes in production, not just theory and concepts. We have a ton of amazing guests lined up for you to hear from, and we're really excited to share their stories and innovations with you all. Our goal here is simple, to build a community of like-minded agentic thinkers who can share experiences and learn from each other as this paradigm shift starts to evolve how we solve problems, exploring what it really takes to build and scale agentic AI, from data and design to governance and guardrails, and to understand the business impact that technology enables. Now, I'm really looking forward to today, as this is an area that impacts the heart of businesses. It's in everything we do in our day-to-day lives, supply chains. I'm joined by Odhran O'Donoghue, CTO and founder of Magentic. Magentic is the AI agent platform for the world's supply chains, helping global manufacturers hunt down and deliver savings with AI teammates called Mages. Odhran co-founded Magentic after working in a variety of roles in the AI space, which included AI research and biomedical science. Today we're going to hear about his own journey, what brought him to founding Magentic, and the types of problems Magentic are solving for their customers, the challenges they overcome, and his vision for where this whole agentic movement is heading. So welcome, Odhran. Happy that you could join us today.
No, absolute pleasure.
Fantastic. So I know it's been a session we've been trying to book for some time. I think it's been pretty busy recently. So
yes, no, it's been a lot of travel internationally for a bunch of clients, and so I'm glad we've been able to get this session in here in London.
Excellent, fantastic. It was great to have you here. And really, before we dive into Magentic, I'd like to explore a bit about you and your journey of how you got here. So I know you've got a really interesting background in AI and research and medicine, studying medicine. Do you want to tell us a bit about yourself and your journey?
Yeah, sure. So to formally introduce, I'm Dr. O'Donoghue, but I'm not the medical doctor. I didn't quite make it to the end of that. Okay. I actually started in medicine as a field, and this was when AI was beginning to take off. Now, I'd always been a computers guy. I spent time building software for my university to teach anatomy while I was still on the medical degree. But it was at this point that there was this real realization that this was going to be the future of the technology, and it was going to have a huge role in the way we worked and interacted and built systems. And so I moved into a PhD in machine learning at Oxford, and that's where I really got into the hard nuts and bolts of how these systems can be useful and can change the way we work. Now, my work historically has always focused on building systems that are safe and understandably safe. This is, of course, very relevant in biomedical domains, in scientific domains. So I led some research, for instance, to Francis Crick Institute here in London. I'm building AI systems that could run and design their own biological scientific experiments. And that was really my background into how we build AI in a way which is designed to not just be like a toy product and be a interesting thing that generates some fun findings, but something which is genuinely transformative to industrial business processes. And you were asking a little bit around how I got to Magentic, because you may think, that's a medical background. What was the guy doing in procurement and supply chains? And there's a few different stories to that. A lot of my work ended up in global health domains. So I worked with OpenAI on global health and natural sciences as well. Mm-hmm. And as part of those experiences, amongst others, there was this real interesting sense that for all the work I could do in medicine working on new drugs that pushed the envelope, the most valuable thing we could do was make existing drugs a lot more affordable and a lot more accessible. And the main thing that drives that is procurement and supply chain processes. And this was the real insightful thing that we have in our world most of the solutions we need to make the world a better place. And the issue is one of access, distribution, and manufacturing. And that for me is a real fundamental thing which is often ignored in comparison to the white heat of what we think innovation actually means.
So that's quite a big jump from sort of research medicine to then, I'll say, the sort of more chaotic world of supply chains, and it's very unstructured there. Is there an unstructured versus structured comparison you could talk to? Or
it's very funny you say that, because in some ways that's what makes the field so similar. We, in science, have rules that we follow. You know, an amino acid organizes in a certain way, a peptide organizes in a certain way. That gives you a superstructure. And it means that information from one system in the world can interface with another system in the world. Procurement and supply chains are the exact same way. We have very standard documents that exist. You have the notion of a purchase order, which describes what's being ordered. You have the notion of an invoice. You have the notion of a goods receipt. These standard documents allow things to be shipped from China to the United States in a way that everyone in those parties understand. And that gives you an idea of an ontology, a framework that describes how the world works. And that's a very, very commonly used concept in science and AI in science. However, at the same time, there is mess all over that. All of the instruments we use in science have noise. We never get a perfect signal. We're always dealing with errors and margins. And in the same way, a domain like procurement and supply chains has the exact same affect. You have PDF scanned upside down with coffee on. You have information that hasn't been entered correctly. You have records that are out of date. You have incomplete systems. And so it's been a really good example of like taking all of this expertise that has been really stuck in these scientific areas and bringing it into a domain where it matters so much to the day-to-day lives of everyone.
Fantastic, yeah. So I think if we were talking earlier a bit about how you met your co-founder, Robin, and do you want to just explain a bit about that? Because it's quite an interesting background there.
Yeah, no, of course. So my co-founder, Robin Vanaken, was a senior leader at McKinsey in procurement and supply chain. So we like to think we know a bit about the procurement and supply chain process now. You know, I can profess to be the domain expert in the technology, but of course we always want to make sure we are directly aligned with what the realities of that world are. But Robin and I actually met doing hackathons together in Oxford. We have a fun accolade where every hackathon we've done together we've won. So we at least knew we could work together well when we started this company.
Fantastic. And you were talking a bit about the sort of the concept of stuff just being messy in the real world, right? And we talked a bit about that before. That whole concept of moving from what is a POC in a very controlled environment, almost a lab environment, in both senses of the word, medical and technology, and then moving to that real-world enterprise. Do you want to talk a bit about that sort of shift? Because you alluded to it. I'd be interested to explore that a bit more.
Yeah. I think there's two elements to that shift. One element is the ability to work with and understand data. And the second element is to build objectives that are genuinely tied to value. So I'll talk about the second one.
Okay.
A lot of work in AI is very exciting. We can show a cool trick. We can pass a benchmark. We can do something really brilliant.
Mm-hmm.
You can have examples of this in, let's say, natural science. You know, we see so many things, our models' abilities to like reason over mathematics, do these very impressive things, retrieve this information. We are beginning to see examples of like models make new scientific discoveries, and this is really exciting. But if you think about the proportion of those relative to the notion of models passing benchmark tasks, they don't really measure up in the same way. And the point to be made there is like there's a lot of work in AI where you can say, oh, our AI has succeeded in parsing this document. Our AI has succeeded in reading this article. That's not the thing which is actually tied to value. You need to make sure that in the production setting, your AI is driving value. Mm-hmm. And this has been the single most important thing for Magentic. The reason we saw an opportunity here is we saw that there is a notion of leakage all across areas in procurement and supply chain processes. You might be ordering 6 screws from different suppliers that are all the exact same screw, and you're paying wildly different prices for them. And you don't know that because they're all described in different languages and slightly different specifications. You may have things which are delivered late that you don't see. I could go on. There are so many different opportunities here in things that go wrong. And it's environments where the AI can really identify this and go and get that value back. And that is a really important component of transitioning from this is an exciting thing to this genuinely changes the way you think about management of these processes and generates financial value from day one.
Right.
Bit 2 is on this data component. Data is messy, and a lot of systems in AI take the assumption that, we will just deal with this level of mess, and we'll say, okay, cool, we're 90% accurate. That passes the bar for most of what we want. In enterprise production, that doesn't cut it. You have really important things like relationships with suppliers. If I'm ordering screws that I need to make my airplanes, I need to trust that relationship with the supplier is based on trust and based on having the right information. And so a huge amount of building genuine enterprise products is building very advanced technologies to make sure the information you have is always correct, and making sure you always have humans in the loop at the right point to act on that stuff.
Yeah. So if you look at the shift that we talked about there, what was the hardest part for you sort of transitioning from a research background into a founder, actually founding a business? So what were the sort of the hurdles for you, if there were any?
Yeah, it's a good question. I think I'm maybe a little outlandish because in some ways I've been a researcher in a way which is perhaps more similar to being a founder.
Right.
A lot of the research I've done has been in teams which I've set up and run and funded, and that changes the dynamic of one of I think the failures of academia is that PhD programs are done in isolation. I think it is one of the biggest limitations of the academic system. I wish there was a way in which we could create PhD programs that locked you in a room with 4 people for 4 years. I think that'd be a much more exciting way of doing things. But hey ho, I could see the complications of setting that up as well. But that meant that for me, I always, it's not that I always wanted to be a founder, but I always recognized that the best way to build genuine change is to build it in a team and to bring that expertise together. And so throughout my academic life, I would always work in projects that brought teams together. I was lucky enough to do some work with NASA through the Frontier Development Lab, and that was an operational team of 5 people, and some of that code from that project now was running on the International Space Station. It's this kind of work where that really sets you up to succeed in a way that is required for building change. Change can't be done alone.
Absolutely. Sort of influencing people and rallying them together on a single cause, I guess, is...
Yeah. Although I make the case that it's often more about expertise. There's a lot of things one needs to know to do things well. And I can have a lifetime forming my craft. I'd do much better with 2 lifetimes.
Great answer. So I want to switch to really about Magentic, the business now, and talk a bit about that. So first of all, I guess for everybody, just tell us a bit about supply chains.
Yeah, they're pretty important. If we think about the largest manufacturers in the world, the things that make up sort of the historic value of the Fortune 500, people that make trains, people that make beer, people that make cars, for these companies, 40% of what they spend is on parts. If you actually think about their spend, they are buying things to make things. You have across the sort of upper echelon of these large companies $3 trillion in procurement and supply chain purchases being made. And that is a huge volume of economic transaction. And the world depends on this. Yes, there are some companies that have more vertically integrated supply chains, but the actual process of procuring goods for the most part is a process of interactions between multiple different parties. This is maybe a simple example in the case of I need to buy a screw. What if I'm trying to organize transport and ship that screw from one place to another? Suddenly I'm then in the case of an open market of all of these different potential vendors. Things can happen because there's been a disruption with a hurricane, as an example recently. Yeah. Suddenly, what does that mean in terms of my ability to get things made to be? The Suez Channel closes. How does that affect my ability to get these items across? Tariffs change. How does it affect my ability to even sell goods at a profit and keep my business afloat? I mean, this is relevant even for the largest companies in the world. All this is to say is that procurement and supply chain processes are an incredibly interconnected web of multiple parties where you have huge amounts of information and a relatively small and well-refined action space, as in recognizing something is late and doing something about it, recognizing you might need to move the supplier and doing something about it, recognizing this item may be sanctioned and of course you need to stop buying that item. The issue is there is so much information that for humans to operate over it, it's incredibly tricky. You're dealing with hundreds of items, thousands of things that you need to put together to tell that story. And then after all that, you need to action on it. Cool, maybe we found breaches of price inconsistencies, and maybe each price inconsistency is $20. That's not that much if you're in the Fortune 500. If you've got 200,000 of them, they're worth thinking about. And as a human, that's tricky to navigate. As a machine, that's very doable. And this informs a lot of how we think about procurement and supply chains. You have the most essential process in the world to getting things done is almost by its very definition is a very broken up and fragmented one full of tons of data where value is not fully captured, because for a lot of these processes, they're not well suited to how humans think. There are many steps of procurement and supply chains which humans are the most important thing for. It's an incredibly relationship-driven business. You have deep relationships with your suppliers. You need to communicate and trust that they can produce items to specification. You have specific financial structures that may be in place which are designed to suit both of you equally. It's not a give or take. It's often in direct collaboration to make these things work. But all of this stuff is one component. The second component is all about dealing with these huge volumes of information. And that's where we as Magentic really come in. We say, we want to manage all of the stuff which is harder for humans to manage and which machines are well suited to, so that you as the procurement and supply chain experts can really focus on the most important processes which you are the lead experts at and which is so important to making the world of manufactured items continue to work.
Yeah. So do you think there's been more of a sort of focus on this as supply chains have come more into the sort of public eye with, you know, the fragility and the unstructured nature of them due to, you know, for example, tariffs, and prior to that sort of, you know, the COVID pandemic and how that sort of disrupted everything? Do you think there's a bit of an awakening out there now of people in industry that means that what you're talking about and the value that Magentic bring is suddenly a bit more relevant?
Oh, massively. I think there's maybe a bit of an internal joke amongst the procurement and supply chain communities where, like, you know, sales has always been like a carrot industry. Like, you know, if you do nothing, you don't really see what happens. If you do well, you get a massive bonus. Procurement is a stick industry. If you do really well, no one sees it. If something goes wrong, everything falls apart and that process is to blame. I think it's a real shame that, like, the industry is often, like, seen in that way, because it doesn't suit and it doesn't reflect the genuinely backbreaking work that people in this domain do to keep the world afloat. And I think the one thing I've kind of been, seems weird to say I've been glad to these things, I think it is really important to see how essential these processes are and how much work goes into keeping them afloat and what that actually means. And it's also an incredibly tricky process because you are optimizing many different objectives. You know, if we're thinking about cost and sustainability, there might be one manufacturer that genuinely meets those sustainability requirements, and it might be the closest manufacturer in a certain requirement, and you go, cool, we'll look in that, and that gives you that ability to meet those sustainability objectives. At the same time, that may completely reduce your resilience, because if that supplier goes under or something happens to them, you can't get that part anymore. At any one time, there are so many different objectives one has to manage to meet the requirements of what is needed. And COVID is a perfect example of just-in-time manufacturing was incredibly important as a process for keeping goods affordable for so many different working families. And as you can see, that was very difficult to square the circle of when you had these shocks to resilience and ability to procure. And optimizing these and working out the best path through these are like processes we as Magentic want to help with and provide information for to allow human operators to make the best possible decisions in these environments.
Right. So that's interesting. Can you talk a bit about the data and the unstructured data and surfacing that to people to increase sort of transparency, I guess, and understanding? And there's also the toil side of it. You mentioned a bit there on the manual processes that exist, the sort of, the paper, the spreadsheets, I'm sure, that sort of dominate the area. Is there a split between the two? I mean, Magentic will cover both of those areas, the manual toil and the data, informational analytical part of it. What's the sort of split there?
The two are intrinsically tied together and they go hand in hand. Right. Really, the role that Magentic plays in this setting is processing all of this unstructured data. PDF in a random drawer, that's relevant to another PDF in a different random drawer in another country because they're actually like an addendum of the first clause. We're pulling that in, we're structuring that, we're understanding these things fit together, and we're understanding what prices these affect, what clauses these affect, what suppliers these relate to. This is possible because we build this ontology of the entire procurement and supply chain world, and we understand how this information fits together. So it's making that information access in a structural way for the first time. And then the second bit of that is doing all the action to actually reason on that. So we can say, hey, look, there's this clause in this contract. It says that if items are, delivered 2 weeks after their supposed ship date, there is a financial penalty for that. That hasn't been enforced. We've also been able to scan these records in this ERP database, which is the structure for most like data and procurement supply chains. And hey, this thing has been delivered late. We know that these warehouses can sometimes be unable to update their records perfectly on time because they have so much going on. We can suggest automating emailing this warehouse to double check. I presented this information to you as a case where every single piece of evidence is shown. Do you want me to send this? And that's the information that's communicated to the human operator. And that's the toil bit. We have machines which are always making recommendations in the most concise way while providing every single piece of evidence to prove why they're making that recommendation. And the idea is you as a human operator can say, yeah, that makes 100% sense. Or it might be you saying, well, actually, I had a phone call with this guy, and it's not a problem. We should factor this in for any future cases that we raise. The toil component is a really important one because if an operation can take a human 5 seconds relative to taking 6 hours, suddenly a lot more things are worth doing. And that informs the way we think about product design, and informs the way we think about information collection. So it's both the getting the information to a format where humans can operate over it and eliminating that toil that drive the way we build Magentic.
So it's almost a compounding there, isn't it? You mentioned there's sort of bits everywhere. It's sort of death by 1,000 cuts sometimes is the dramatic term they use in that. So how do you know where to go and look? And maybe this leads on to your majors. I want you to talk a bit about majors and what they are. But how do you know where to go and seek out these sort of areas where you can find these sort of shortcomings?
Yeah, I mean, so when we say majors, it's what we use as our. I'll be honest, we like to have a bit of fun branding here. We're a company called Magentic, and we really mean that as meaning magic agents.
Got it.
And we talk about majors to really mean our AI agents that take operations to provide value. And when we think about building a mage, we think about what is the actual process that is guaranteed to create financial value. And I think we're lucky that there are precedents in the industry. Consultants come in and do exercises in consolidation to understand are you buying duplicate parts. We know there are inefficiencies that happen at various processes. Sustainability is incredibly important, and people do work to do sustainability mapping. The fact remains that a lot of these processes have existed historically as isolated single-serve processes that cost millions of pounds and just get done once and then forgotten about for the next 4 years and then get done again when you go, oh, cripes, we've had 4 years and all this stuff's fallen into disarray again. And we say, look, we know these processes are incredibly important. We're going to be running these processes every single day. And these processes are going to be driving business decisions and business value all the time.
Right. Okay. Interesting. So you've built Agentic around this, I think it's no cure, no pay model. That is really interesting. I'd love to hear a bit more about why you've done that and how that's working out for you as a business.
Yeah, this is a really interesting one. So I think this goes back to a bit of us backing ourselves. An issue with the AI industry as a whole is there's a lot of vaporware. There's a lot of things which profess to do something valuable. And yeah, cool, maybe they've rearranged the process. All of that can be like a shiny sheen on something which is not actually driving business value and business change. And for us, a real key element of being committed to showing that we can change businesses is saying, hey, look, we're going to generate direct financial values for you. We're going to get paid when you actually get that value back. And that is so important to keeping us accountable to building these systems in the best possible way, keeping us aligned with what's actually needed in these procurement and supply chain companies, and also proving in our pilots and our processes that these things are worth exactly what you're paying for them. And that helps a lot in the way we think about building. Will this be what we do for every single major we develop? Not necessarily. There are some majors where measuring financial value is a little less tangible. A good example is this in things like renegotiating contracts, which is a lot of work we do right now. But for so many other processes, it is very easy to build things that have measurable value, and we think that's really important because I don't think it's worth doing something if you can't measure why it's worth doing. And the more comprehensive and more sensible those metrics are for measuring why it's worth doing, the better it is. you can have an AI system which reads and scans contracts, and you're measuring how well it accurately reads and scans contracts. Your system that's 99% accurate is great. The system that's 98% accurate, is that worse? Well, what is that system that's 90% accurate connected to? Does the 99% accurate system then just like produce information that can't be processed for any downstream task to generate value? Does the 98% accurate system then know why it's inaccurate, prevent those things from happening, and in the situation where it's 98% accurate, generate financial values and savings? That is important to us, and it's the reason we price on value recovered and proven value recovered.
I mean, it's unique. It's what a lot of people say they want: outcome-driven contracting and agreements. It's a partnership model, right? But I think people are often used to buying people's time, buying seats or widgets or software as a service and such. Have you found that's been a big shift in your discussions with businesses as you sort of arrived at that model?
Yeah, and it don't get me wrong, it does represent a paradigm in pricing. And, we're lucky enough that we work with very large enterprises. And it means we do spend time making sure that like the deals we have and the structures we have for pricing are really suitable for what an enterprise needs. Like they have different financial structures that necessarily creates complexity in terms of like what is required. And I'm kind of glad that we operate with the size of companies we do to make sure those things work. But whenever we're saying we need to make things work with the company, it's always with the objective, how do we keep both of our objectives aligned? Whenever we're going into a company, we always want to be in a situation where we win when they win. Yeah. And despite this being a new pricing model, relative to like the historic SaaS seats-based stuff, it's really clear that the largest companies in the world are so aligned with that, because the fact remains that the procurement and supply chains world are facing these very uncertain times. We are in a very uncertain world, and that does affect how people think about like finances and new softwares and new services. And, blindly believing that a piece of SaaS that costs $2 million a year and doesn't do anything valuable is maybe secondary to something which is saying, hey, look, we've done a pilot in the process with you guys. We've demonstrated financial savings already. You're paying us for what you get. And we find that even though these are new pricing models, that does go down pretty well. Right.
I mean, if you're looking at KPIs, so I assume you're using KPIs to measure that through.
Yeah.
I guess in the world of Agentic AI, we talk a lot about observability and sort of evaluation of whatever criteria, and sometimes that can be somewhat hidden maybe. And how do you set about defining those KPIs, and so that your customers have success criteria that they fully understand, and you map that back to what the majors are doing in reality inside their environments?
Yeah, so there's a few. We can talk on observability first, because it's one which we do very differently in Magentic.
Okay.
Our AI systems never make an external action without a human approving them. They will say, hey, I've got a suggestion for something to do. And whenever they make a suggestion, they have to get the exact evidence that proves why they're making a suggestion.
Oh, wow.
Here is the screenshot of this part of a contract that says there's a late delivery here. Here is the exact command I ran in your database to get these records out to show where they match. You can trace this back to the exact system. Here's the email that I'd like to send as a draft to follow up on this with a supplier. Do you want me to press send? Suddenly this notion of observability is directly tied to the product itself. And our metric is success pass. So, how many times does the agent give a case that a human goes, yes, it's 100% correct, and time to accept. I'm a big fan of this idea of single metrics, as in if you are building a company, it's good to have one metric that you measure as your golden metric.
Mm-hmm.
The metric we use is dollars per second. How many dollars of value can a company save per second of interacting with our platform? And that is verified, as in they know that they have the exact information from the evidence model is presented to say this is the exact source of truth and the exact way in which you understand that this is correct. And you can verify this in 5 seconds. And with that email can then be sent, and if a supplier emails back and that process continues, the model can work out what to say next and manage that and keep that process going. And so that's the bit on observability. That's how we measure observability.
That's pretty interesting, because from what I see, there's a lot of ambition out there from exec level down to wanting to sort of remove humans from the process entirely. And we see the scaremongering in the news about AI will take your jobs, etc., etc. But what you're actually saying there is interesting, because in reality, there's still very much a role for humans, and human in the loop is often seen as some sort of fallback or failure, as the fact that the autonomy has failed and therefore it now needs a human. But what you're saying there is quite interesting, because it means the human's actually part of that process and they're still relevant to it.
Yeah, I mean, we see that as essential. Like, for all of the processes that you could say, oh, we can quote unquote make this fully autonomous, we as humans are the ultimate beneficiaries of value, and we need to have a role in shaping that and defining what value is to us and what it is to our companies and what it is to our processes. And a machine can take a guess at what that value is, and that guess can be often very aligned, but our values may change, our needs may change, and if we don't have a human in the loop at certain parts, like, that's not always going to be in building what is required. Like, a great example is we may have a genuine financial breach that's like come up with a company, and we have often our models will say, hey, I can enforce this breach. Alternatively, like, I can just send a warning, like, we can note this down for further time, because like this relationship may be quite important with the supplier because you guys are planning something, and that's really important. Like, our models don't have full awareness. Like, we're not going to enforce a breach where that one supplier is the only supplier that can like make a new really interesting research product that these companies are considering at the moment. Like, if we don't make sure that humans can always be involved around what they need for value, that really isn't a product that works well for what humans need and what we need as a operational society building advanced manufacturing goods.
Yeah, right. So you mentioned a few times that you saved millions for large manufacturers, right? Which is fantastic. I saw it on your website actually. But what's that? Without sort of oversharing too much information, because I understand that probably isn't possible. What's that breakthrough moment? When do they see that, and what does it look like? As I say, just generically, what does it look like for them?
For these large manufacturers, it looks like they can see exactly what has gone wrong, and they know that the process of managing it is going to take them very little time at all. It's this evidence thing, which I think really clicks for them.
Right.
It's also the trust that they can be the guardians of what to do with that evidence. Okay. Like, it's one thing for a model, like, I think one of the really exciting things about, I'll maybe frame this a bit differently. Like, SaaS has historically been the domain of dashboards, and we'll start a demo often with signing with a client, and we'll start with a dashboard. It's like the historic origin, and they'll say, okay, cool, dashboard. I can see these things going wrong. I can see like these pricing discrepancies. And okay, cool. Let's actually click on that, and then from there we'll load up a case which shows a specific set of discrepancies that are like easy to operate over together, and they are brought together in an evidence view, and the model saying, hey, look, here's the actual problem, and the manager can go, oh yeah, this is 100% correct, and I can verify this is correct in seconds. And I don't even have to like think about the email I'm drafting, the downstream steps. Like, my model's going to manage emailing that supplier, updating that record in the database, contacting the finance staff to make sure that credit note gets reimbursed. And that is the bit that clicks. It goes, oh, this thing that like would take me hours, if not days, now takes seconds. And I know this process is worth doing. I hire, consulting projects. I maybe take like a month of my year to try and like do this manually and see like the scale of the problem. Like, I do surveys of these to like see how much is affecting my process. I don't have to do that anymore. That is the bit that really clicks. It's not the dashboard view, it's the post-dashboard way of thinking about technology.
Right. And the savings, I guess, come from process improvements, quality improvements, reduction in error, and obviously contract leakage. And does it come from headcount repurposing as well? Are they able to repurpose too? Is it purely focused on the former too?
No, like as we said, right, we see procurement and supply chain processes as being like the most essential process, and we don't see a point in building Magentic in a way which is designed to reduce headcounts. Like, right. These technologies are there to assist. Like, we've got stuff we're working right now around like contract negotiation, and that is often around supporting people in person, live, head-to-head negotiations.
Yeah.
Like when we want to build in such a way where if there's a notion of repurposing, it's a notion of humans being able to spend more time on the things that drive value that they are incredibly well suited to do. Negotiation is a good part. Sourcing is a good example. Like there's also this really interesting concept of like procurement engineering, where you may build a very advanced product and you go, actually, well, like we want to change the way we build this. We build technology to support this so they can understand like what the layer of like possible components are. But we would always argue that the world needs more people working in procurement, and Magentic is there to mean that no matter what happens in the world of procurement, more and more can be done to make it work better. Like there is no world where we can't always do a better job in this process.
Yeah. I mean, I was speaking to someone the other day, and they were talking about the fact they're sort of operations people and operations teams who had previously just been processing, records and purchase orders and stuff as they came in, had actually changed the nature of their jobs. They alluded to the fact that they become prompt engineers because they needed to understand the agents and even adjust prompts depending on changes within the business. Are you seeing any of that sort of reskilling, so we say, people having to work in different ways, and what are people's reactions that are touched by Magentic?
Yeah, so when we think about like skills needing to change, a comparison I always like to make is the great computers revolution, where people started doing finance on the computer, and there was this big narrative of, we're not going to need bankers anymore, everything's just going to be computers. And post that system, the finance industry exploded and so many more roles were created. And that was in part because this technology allowed people to do so much more. But one thing I think is different here is the way in which we interface with technology. Like the first technological systems we made were deterministic, and you do a behavior in one way and it would always do the same thing again. And as a person who's in an industry, learning that skill is, something which is important. The thing which I think is different here is we have non-deterministic systems. You can put in an input, and yes, you can make them deterministic certain ways, but in most of the ways in which they work today, like they don't always produce the same answer. And so I do think that like we think a lot in Magentic around making sure people can use this technology in a way that allows them to transform and change. And part of that is making it consistent, reliable, and making it deterministic in the behaviors that matter. And we don't want people to just be prompt engineers, because it's a stochastic and deterministic process. You've got someone like trying to write a prompt, doesn't do the right thing, trying to write another prompt, doesn't do the right thing, trying to write another prompt, doesn't do the right thing. And even after all that, it still might not do the right thing at the end. Like that for us is like, yes, cool, we can call that a shift in like how people work and what people do, but like it has to be more than that. So much of like the way our systems work is like a human will say, hey, I need to adjust this flow, and the model will say, cool, here is I've used this notion, here's the deterministic flow I'm now going to run through this process. You can see this and trust that this flow will happen like this. Like these are the ways in which we also change the relationship between human and AI. And that for us is really important to making these tools that are things that people want to learn to use and things that people know will help them consistently and reliably in the way they expect from technology.
Right, okay. So I want to come back to majors because I'm fascinated by them, and just a bit more around what they are specifically. So say I'm working in a manufacturing in my role, and I turn up for work on a Monday morning, and last week your team, I'm not saying it would take a week, but last week your team had been in and deployed some majors to sort of change how we're working and how the business works. What would they look like? I mean, would there be specific majors for, say, procurement or for pricing, or your suppliers or vendor management? I mean, do you have a a library of mages that you use and you configure for? Do you build on those? Do you custom mages depending on the individual company? But how would I see those things in my business on that Monday morning?
Yeah, so we built a library.
Right.
We think that's really important because AI technologies change so quickly. Every week new capabilities can come out, and we want to very clearly bound what a certain mage can do. And it also allows us to graduate mages. We have ones which are built around, like, let's say, price leakage, where we are going after like financial recovery of inconsistencies between contracts and records of what prices are actually sent, and that's a very popular one. We have the one around consolidation, which are used. But when we build these, the goal is to say, we know the technology is mature enough for these domains. There are other areas where we think the technology is not mature enough yet for certain technologies, but it doesn't mean we don't prototype them, have them running in the background, and we're constantly evaluating whether or not they'll be suitable. And it's the reason we like the notion of separate mages, because it's a promise that we have genuinely assessed the validity and the suitability of technology. It's also like we do have exercises every now and then where we go into a very large company and they say, hey, we've got this really interesting problem in this new domain which is transferable, and we'll go, yeah, let's see if we can build something that really works in that setting. Now, that's often it has to be a win-win for us. We often care about, will this generalize to other domains? But we're always really excited to work with companies where they're willing to say, let's experiment and let's see if this works in the way we hope it will. And, we've been pleasantly surprised. We've worked with, multiple members of the Fortune 500 where they've said, we really want to try this thing and see if it works out in the way we hope, and we'll always get our fingers stuck in it.
Okay. So, if I use a term sort of composable sort of architecture in response to the fact that you've got an LLM and then you've got small language models, and there's often this debate between LLM generic models versus specific models that can sort of carry out specific tasks and deliver specific outcomes. I guess with agents, there's a similar sort of debate, these generic agents that you get that are sort of master of all versus ones that are really specific. What's your view on the split of that, whether you go specific or you have sort of more generic agents, and what are your lessons learned in that space?
This is a fun bit. There's bits I can't say on this because we do have some IP.
Fine.
But I guess you're probably alluding to the NVIDIA paper that came out a while ago around large language models, should maybe be replaced by lots of families of small language models that are specialized in certain domains.
Yeah.
It's a really interesting paper, and I'm a huge fan of the NVIDIA teams that work on this fundamental language model work, their historic work on things like Voyager. Sorry, I'm rambling about AI stuff, but yeah,
it's good.
Those teams are great.
Yeah.
But the picture is not so clear cut. Okay. Building a model and training a model can sometimes come with competing objectives. And making a model good at one thing, it might be not good at another. A great example is reasoning models. We've seen a lot of ability to improve the performance of models by making them reason in text. They'll produce a model and then they'll go into sort of post receiving a question, reason about the answer. And this can cause a performance increase. At the same time, definitionally, you've reduced the latency of that model. That model has to think in active time rather than producing a response straight away. And that is a trade-off which affects some of the utility of that model in certain domains. So no matter what happens, we are going to have models that have certain things they're better at and certain things they're worse at. And we do need to build systems that deal with that. Maybe a little hint I'll give is that language models are not the only technology you can use. A language model is a system which outputs, at the end of the day, probabilities and weights. And the nice thing about probabilities is they're composable. We think as language models as being an incredibly important component of the system. There are small things we build around those that also significantly enhance our ability to perform consistently, reliably, and in a way which doesn't ever make a mistake, in order to provide the genuine value that's needed in the procurement and supply chain industry. Okay,
interesting. I look forward to what you've got in, coming on in that space. So obviously we need to talk about ERPs that have been in sort of supply chain and procurement for decades, operating in a very deterministic fashion, and there's a lot of sort of monolithic solutions out there that I'm sure you're coming across. How do you work with the ERPs, and what's the general direction you're taking that with your solutions compared to them?
Yeah, this is an interesting one. The notion of a centralized ERP doesn't really exist at the sort of companies we work at the scale we work at. You will have companies with, potentially hundreds of subsidiaries. That's the reality of large corporate businesses. And each one of those might have a different ERP. Or it might be that, and to clarify, when we mean ERP, we need enterprise resource plannings. These are historic database and transaction management systems for managing the flow of information around purchases, goods, services, materials. The reality is these systems are very fragmented. You might have one system for your direct procurement, i.e. things which are used to go into the materials you're making. You might have another system for your indirect procurement, i.e. your chairs, your office supplies. You may have different systems in different geographies. You may have some records that are stored on databases, other records that are in SharePoint folders. You have to work with that noise. And we take the perspective that a lot of people make the mistake of saying, oh, I can see 26 different, inoperable systems. I'm going to build this new universal standard that's get them all together, and I have 27 different inoperable systems. At Magentic, we sit on top of the ERPs. We don't try and be another ERP. We say, there are all these different systems. We have the intelligence and the capabilities to ingest data from any of them. And that's, part of the huge amount of AI work that we've done is to build things which can very safely and securely adapt on top of these systems and take data from them. And that allows us to be this centralized vision of data to then go and recover this value and get this back. And that's the way we think. We say, there is a layer that exists on top of the ERP level. And that's important for doing things like managing email communications, messaging teammates on Slack to understand where information might be, searching for information that doesn't even exist in the ERP. If someone's had a phone call and that's not written down, that's not an ERP record. That's how we think about working with the ERP systems. Integrate with any ERP in existence and set a layer above it to provide value.
Okay. So we were talking earlier about a school of thought that, ERP's days are numbered, certainly in the current sort of format, so we say. How do you see Magentic evolving if the ERP landscape shrunk away and was replaced by something else?
So I'm not sure if I agree with the stance that ERP's days are numbered. I think the thing about ERPs is that they've become a language in themselves. We'll take the example of SAP. SAP is I'd argue a company of structural importance, the same way you have a bank of structural importance. The way SAP defines its tables and defines its relationships is in many ways the way procurement professionals think universally about the way in which procurement information is structured. And there's of course lots of exceptions to that. There's lots of, the ERP field is famously very diverse, and there's lots of different systems in play at different scales. But I don't think that the ERP systems are necessarily going to go away anytime soon, because they form a lot of the fundamental work of these companies. I do think that there are paradigm shifts which are happening. A lot of ERP systems are moving onto the cloud right now, and that changes the way in which data can be available and how data can be used to drive value. I can see that there's a lot of new types of ERP systems that are really exciting, and people are really interested in considering changing and moving to a different ERP that has new features and new ways of building. It doesn't erase the fact that the ERP as a system is one which is so fundamental to the way manufacturers work. Now, what I could see is the greater capacity for communication between different systems. An ERP is one system, it doesn't exist in isolation. Maybe the way you manage freight and transport is different. Maybe the way you manage your products and your bills and materials is handled slightly differently. And again, this is one of the really exciting things of a company like Magentic, where we sit at the agentic level above all these systems, is we exist a lot of the time as the interface between these different things, so they can talk to each other, and so you can find value. And that's really important to the way we build.
That's interesting, really interesting. So I think, often the history was that I've installed an ERP, and this is not the case at all, we know this, that's done, right, rub my hands, done, job done. I think the reality of it, as you say, is there's lots of disparate systems, and even having a consistent ERP, for example, an SAP system, still that can be implemented in very different ways in all different organisations. Very rarely are two the same. I think that brings up the challenge of data. You got structured data, but there's sometimes there's been attempts to create consistent data models in banking and manufacturing over the years to have a standard. Telco have tried it famously. That rarely seems to have worked because you always have immediate requirements that sort of buckle that model, so we say, and move them away. So the reality of it, I think, as we were talking about, is that there's lots of different data structures. Even structured data is not against a standard format, and then there's unstructured data, which is just organically grown SharePoint you gave in these PDFs hiding in drawers and such. How do you, what's your view on the future of that? And how? So first of all, how are you working with that with Magentic in that reality we have at the moment? And what's your view on a future state that maybe addresses some of those shortcomings in a more sort of autonomous world?
So we already deal with that. The whole reason we build agents and systems is we say the world is incredibly unstructured. We exist over that layer and we provide value. What's important to us is like us having conviction that like a major will work. Like we go into certain clients and we say, okay, you guys have this data. We always have a baseline where we know in any enterprise we work with in a certain industry, like these majors will work even if the data is very poorly organized, very disparate. There's a chance some agents we have might only work in certain geographies because they only have like certain bits of data available, and like that's not a problem, right? The promise of a mage system is never saying we are going to be the new ERP. It's saying we're going to save you financial value, and we're going to deploy these mages in the environments where the data is present for them, the systems are present for them, and the information is present for them. And as course of any initial exercise, the first thing we do is do proper scoping to show where these things can work, and that's the way we play. Like, we think AI helps massively with unifying and harmonizing the systems. It's not a wizard. It's not a magic bullet that suddenly means everything can be fixed. Like the problem, for instance, of entity matching, which is kind of core to this idea of like harmonizing systems, is an NP hard problem. Like that's not a problem which like, unless our AI proves that P equals NP, which, cool, I'm out of a job. And when I say an NP hard problem, I mean a problem which is like computationally very challenging to solve in a quite formal definition of that. These things have to be considered and worked around, and you can't magically wave your hand away and say, we'll just magically solve it all. Instead you say, we are building systems which acknowledge that things might not get better in terms of having different ERPs all over the place. And we're saying that's probably the reality going forward indefinitely. That's not a problem. We just need to understand the bounds of that reality and build systems that create value here and now based on that. Right.
And what does 5 years look like?
Oh, good question. Very hard to have timelines these days. I think for us, it's about significantly expanding the family of majors. We do a lot of work on procurement and supply chains, and we take steps up through various levels of advanced manufacturing. Like we are at the level now we do really exciting things with automotive, and we're getting touches on some bits in aerospace, which is, these are getting pretty advanced, as you can imagine. There are things that get more advanced. Like I'd love to see if our technology can be useful in like semis, for instance. There are components where we want to move further and further up, like highly advanced manufacturing processes. Obviously, I'm lucky enough to have that medical background, so we're always very interested in working with pharmaceuticals, where there's a lot of specific tooling we're interested in deploying. But that's where I see the future is like, it's not saying, oh, we like can do more ERPs, but we can do them all already. It's saying we want to be able to work with any company, no matter how advanced it is, and make sure that the technology is appropriate and suited for those bounds.
Okay. Because I think I looked at when I was doing some research, that MRO is somewhere that you maintenance and repair and optimization, as well as, are you looking to move into sort of the more asset management areas as well? I mean, with sort of plant and there's lots of sort of other areas in that sort of supply chain space, which is away from the sort of more sort of I guess order to cash and contract value leakage and areas you talked about already. Are there other areas you're looking to expand into around?
Yeah, no, this is an interesting one, right? Because I mean, I'll give an example. Like, there's some areas where a lot of the actual important financial work just happens over phone calls. And funnily enough, like if that data is like not recorded anywhere, our AI can't do much about acting on that to spot the issues in value. We've always been focused on like corrective value for the most part. We're like saying, okay, this thing has gone wrong, let's fix it, or let's identify this thing before it goes wrong because we have a record of it. Another thing which like we're really pushing on internally is how do we then get involved in certain process where we generate value. So examples are like managing certain things on phone calls. This is a technology which I think by our current internal metrics is like not mature enough for some of the things we would want to do with it to create value. And it's the reason we don't ship that actively yet. But it's something we're always testing internally to see if it can reach a point of maturity where it generates value. And that's the 5-year thing. Any of these technologies could get radically better in a very short amount of time. And we're always really excited for what those possibilities can be and what new majors it can then lead us to then producing for the largest companies in the world.
Okay. So obviously as a global level, and you're doing a lot of global manufacturing and global companies, how do you deal with sort of localization? I'll elaborate more. What I mean by that is that often organizations aspire to having this sort of core centralized way of working, centralized template of processes. The reality of it is that all different countries, business units do it in a very different way. And that could be driven by just ways of working. It could be driven by local policies, tax compliance, what have you. How do you deal with that complexity within Magentic?
I mean, that's the whole point of having an agentic AI system. Like, our systems go on the ground and they, as part of their setup, like work with people, and we work with them and say, hey, what does this flow actually need? Like, and that flow's configurable by them. It's adjustable by them. The way it prompts, the way it responds, like, is really important. And that is as much a effort on building a good product that people want to use as it is an effort on building good AI. Like, we're always targeting an NPS of above 90, and with our pilots, we've got that. And that's because people like how they can customize it for their local flows.
Right. So you wouldn't have a French mage and a Spanish mage and an American mage depending on countries. You'd look to a procurement mage covering all countries and adapting. How do you sort of split that out?
They're kind of the same thing, really. Like, we have a mage with central capabilities, and it has local ways of working.
Right. Okay. I know the reason I ask this question is because there's been a struggle in the past in the non-deterministic world, and I guess the positive here is that in the sort of the agentic world, that may actually go away to some extent. That may get sort of alleviated to some extent.
Yeah, it's important to design products in a way where you acknowledge that you are not the expert as the technical company for how someone works. Now, obviously, one thing that's useful with these technologies, they give visibility to global and different processes. Like, something we found, which has been like really exciting for us as Magentic, is like, as part of our process of like deploying these, it's the first time that global offices who kind of coordinate everything and being able to see like what these processes actually are that get run, and they get process visibility across all the different local processes. And sometimes that leads to a conversation around saying, hey, maybe this process should change. And Magentic has a very good active role in making suggestions on process changes. But there is nothing wrong with a process being specific to a geography, because geographies have specific requirements.
Right. With how much process work do you have to do at the start? Because I'd imagine there's a bunch of business analysts sort of, how does that department work? How does this department? There's sort of more purebred consulting before you can then start to apply Magentic and Mages to the problem statement. How does that work?
This, I think, is something we've already done the pre-work of. It's the reason Robin was a expert in procurement, supply chain consulting in the largest companies in the world. Like, we know what's needed. And we stick to deploying majors that we have certainty will work in the context and have the right setup and requirements. And that is what matters. And I think, the thing that is, as I said, the thing that grounds us is that, like, in order to have something shipped from China to the United States, you do have standard forms, you do have standard processes, and you do have logic which scales. And we have to do a lot of work identifying what logic scales, and it massively informs the products we build. And, we're a business. We want to do things at scale, and we're going to build processes at scale. But that's also a massive advantage to the businesses we come to, because they don't spend years setting up our product. Like, we run pilots in 6 to 8 weeks, and already we're saving financial value. You compare that to like some ERP changes and suggestions, like those take 1 to 2 years to integrate, if not longer. And we do this because we know the domain's working, and we know how that value is recovered. We have the process set up, and we can run that end to end.
Is there ever any tension there with global process owners that say, no, we do it like this, and you're saying, well, this is best practice and what we feel is probably better for your organization? Is there any tension at that?
It's not tension as much as it is we create a core process. Like, the process has these steps.
Yeah.
There'll be the little bits which are very quick to adjust. But the core, if you think of a process as like a tree of branches, right? The core of that tree, the trunk, is the thing which generalizes. And if you know how to expose the branches in such a way, that's actually really exciting for like a global lead, because they'll go, okay, cool, this process like is already there. I can then chat with the agent to configure this for an extra 15-20 minutes, and it's done. Yeah,
fair enough. So switching a bit to data now, so and sort of more compliance. I mean, compliance is a big thing in the area you work. I mean, SOC 2, ISO, GDPR. I would imagine that's a sort of, you live with that. And researching what you do, you sort of built your solution ground up, adopting those compliance standards. Tell me a bit about that and how you work with that.
Yeah, so my background is working with medical data. I'm used to the highest possible standards of data protection. I take it very damn seriously, and I think it's really important in terms of how we build products. We build our product in such a way that we can deploy it in any cloud environment in an entirely secure, isolated way that's deployed in like one version per client. And that's really important for guaranteeing complete isolation, guaranteeing that we can work with different language models. And we even have situations where like we can work with clients' language models where they've got them specifically trained in certain secure environments. And if you're building for an enterprise client, it has to be taken seriously. I think it's one thing which I kind of worries, maybe not the right word. For any large enterprise, you will use the tools that you have available to you. And if the only tool is an insecure one, people will just flock to that because it's the best tool for the job. I've had multiple friends who work in law, and the amount of times they get internal emails going around saying, please stop using an open LLM for doing this work. Yeah. That's reality what happens in a lot of businesses. Yeah. And we never, ever want to be doing that. And that meant that from the ground up, we built systems that were not just secure by design, secure to the exact needs of an enterprise client.
Right.
And I mean this in the sense that so many enterprise clients are different.
Yeah.
Like we have this notion of like an enterprise manufacturer being a type of company. It's really not true. If you look under the hood, like one soft drinks manufacturer may behave completely differently from another in terms of how much structure and what it needs and what it requires. And it's why we focus so much on this idea of like we can deploy anywhere in a single environment specific to that company, because it means we can meet their exact needs as an enterprise client.
Right, so again, it's no one size fits all. Regulatory requirements are broad brush. You're saying actually
it's building a technology that can fit to any size.
Yeah,
that's the way we describe it.
So there's a bit of concern in industry around the sort of black box decision making around AI, and again, maybe it ties back to what we talked about on traceability, observability. Yeah. But how do you alleviate that concern that it's not a black box? It is explainable.
It's the traceability thing, and it's I think it's something we always encourage companies when they are assessing AI. You can't have your decision-making process be a black box. Yeah. Let's say you benchmark a system on a bunch of contracts, right? Cool. Sure, maybe that model is like 100% accurate on those contracts. You can't see that reasoning. You don't know how it got there. Maybe those contracts were just in its training data, and it just knows what those contracts are. And like, if you can see the reasoning trace, you can see the model goes, I've seen this before. I've just worked this out. Cool. You've built a system which you had no way of understanding its reasoning and how it works, and now you deployed it in production, and it's tanking because it's working on data outside of its training data, and it doesn't generalize well. We focus so much on the way we built our product on showing evidence because it allows for that traceability and it removes that black box element to how the AI works. Yeah. And that's essential to any process we're doing.
Absolutely. So I want to talk a bit about how you get your customers live and that sort of onboarding and that time to value, is how I like to call it. I actually noticed, I want to talk a bit about the FDE model because I notice you're hiring FDEs, and I don't know if you're able to talk about that, but I'd love to get your view on why that FDE model, which has got so much sort of publicity at the moment, is very much sort of flavour of the month, shall I say, from the Palantir type sort of model, moving that forward. Why is that approach so prevalent in the industry, and why are you hiring for FDEs as well?
With forward deployed engineers, as the role implies, there's a few different ways in which people think about what an FDE actually means. And for us, the most important bit is the forward deployed. Like, our FDEs go on site with clients, and they're really there to get into the weeds of like what they want and what they need. And I think that's incredibly important because, while we build our technology to generalize in such an easy way, as you mentioned, like, the trunk is there, those branches still need to be set up in a way that works for people. And on top of that, like, while this is a very seamless change in process, it's still a process change. Like, it's still a technology which is new and different. And we always want to make sure, as a company that works with large enterprises, we are there to provide the best possible service. And the role of the FDE is so much around, like, being there on the clients, working with them, understanding their needs, and making sure that really delivers what they want. Indeed, it's one of the reasons, like, we often hire FDEs that speak quite a few different languages. It's something that matters a lot to us. Like, we can operationally talk to someone's head. Like, we often want to be like talking to the heart and really like making sure that this technology is what they want and what they need. And of course, the second bit of that is it's the best chance for us to really understand where we can go next and like what we can bring forward with Magentic. We love, like, our clients love having our team on site because it's for them the best chance to bring up small things that happen. So like, hey, this thing's really cool. There's this one like thing I'd love to be able to do with the platform that isn't a capability yet. And we go, great, let's knock this out and we'll have it ready for you in the next few weeks. Like that loop is so valuable, and it's a loop which becomes much more valuable for both us and the clients we work with when our team are able to be with them in the day-to-day of their process.
That's fascinating. So you see, look at the types of work you're doing. You've referenced repeatedly it's weeks, not months. So there's a lot of the time to value is pretty aggressive, and it has to be in this day and age anyway, and certainly within AI, people want results fast. But you've got a lot of different skill sets there. You've got product related skill sets, you've got engineering related skill sets, you've got business analyst skill sets, as we talked earlier. You've got technical skill sets, being able to code something quickly or deploy something quickly, and then you've got the sort of operational side of it. I mean, I'm not sure all that exists in a singular role. I think people talk about FDEs as some sort of unicorn role. Is it a combination of people within teams on site that you see? Or?
So I think the reason the FDE sometimes comes up as a unicorn role is it can mean a lot of different things. Like, let's say that Palantir FDE is like very formalized, and it's often like, if I compare, like, let's say something like Magentic to Palantir, like Palantir is a company that makes like quite generalized technologies in their core product team, and FDEs like build a lot of engineering work on top of that to make that run. They look in some ways more like software engineers. If you compare it to the way you think about the company like Magentic, we build a very focused product for a very specific thing. A company like Palantir does like so many different things, and that's great for them. It's a business model that works. We say we do the specific thing of procurement management in supply chains for large manufacturing companies. And by having that very strong core product, the amount of work that happens on like the FDE side to customize to build is much smaller. And so for us, the FDE changes the focus to less from, I don't need an FDE who's there writing reams of codes for a client. That's what the product's for. Right. What I do need them to do is to be able to say, hey, this is the way we're expecting to escalate processes and value. Like, does this make sense for you? Hey, these are like the first cases we had coming through showing breaches. Like, do these make sense? Or like, is there a thing where like these warehouses can be late? And like, if so, here's how you tell the model this, and the model can go, cool, I now understand that, and I'm going to change these cases from here on out. These bits are at the interface of human process and technology. And it's also a role which is new. We often see that the best candidates we have for these roles are younger, people who've kind of been AI native, working with those technologies and are focused on communication and data literacy, but that's as part of like a wider skill set that they have. And we're really excited to be working with them.
Absolutely. It's an exciting time for sure. So if we look at a new client, and we talked about a value-driven approach, which is fantastic, makes a lot of sense. How quickly can a client expect to see value? What does that look like? Is it sequential? Is it late? How does that get sort of tabled? We talked about the KPIs, but how does it typically look on an onboarding, so we say, scenario or project scenario?
I mean, like, we don't start a pilot if we don't believe we can recover value in the pilot period.
Right.
Simple as. Like, this is the conviction we have in our product, and this is the way we build. Like, if we're going to do a pilot with someone, there's no sense if it doesn't generate value in the pilot period.
That's it. Sort of go big or go home, right?
Exactly.
Okay. So, personally, what excites you about the AI space, and where is it going?
It's too early to tell. I think, the fact remains is that AI moves incredibly quickly, and we are really punctuated by sudden shifts. Like the introduction of the transformer model was like a complete shift in like the way we generated components for AI. In the same way, the introduction of diffusion models was like a big shift. And so you never quite know what's going to happen when like a new technology like shifts the paradigm. What I think will happen right now is a shift in the way we think about tooling. I think one thing that is maybe a bit of a weakness right now of the industry is a lot of tooling is built with the assumption that AI is perfect. And, we'll have a system write reams of code and do wonderful forwards and backwards loops, and observability and traceability is poor. I do see that in like the short term, I see more things acknowledging that like these systems are stochastic and non-deterministic, and if you don't build them in a way which acknowledges that component of the system can make mistakes, then it's not a perfect system. And that means building other components to the system that can't make mistakes, and building these as part of the actual way in which the system works. It's the way we think about it in Magentic, but I also think I think it will reflect a wider industry trend towards this model of these models existing as part of like a system and systems of systems. I think another trend is continued advancement of protocols. So obviously we have protocols like MCP and A2A. These protocols are really exciting, and they've made a lot of like tooling very accessible. They're not the be all and end all, and certainly like there's lots of people in the industry that say like certain parts of these protocols have limitations, and I'll be really excited for how we think about evolving these protocols to address some of these limitations as we go forward. But that's not really on the 5-year horizon, is it? That's I'm giving you like I don't like to make plans that far ahead, is the way I'd say it. I can give you a year out. 5 years. God knows.
Exactly. It's a long time in this day and age. So just switching to, as a founder, what would your advice be to other people that are looking to found businesses, startups, wherever they are along that journey? Any good bits of advice you could offer them?
Yeah, I think there's like two types of founders that exist. There are people who have always wanted to be founders, and they go in to start a business because they want to start a business. And there are other people who get a lot of conviction on a problem that they see and deal with and want to solve it. Neither is right or wrong. I've known a lot of people who've built unicorn companies after pivoting into a completely different idea. And I know we talk a lot about the pivot, it's a failure, right? You built something, it didn't work, and you're trying again. And that means that you don't necessarily need a problem to start with. But I really like building with high conviction. And what I mean by that is Rob and I spent a lot of time thinking about this problem, researching and doing it end to end and believing it was the right thing to do before we said we want to build a startup. And for both of us, building a startup was not necessarily the end goal. I've been an academic. I've worked with nonprofit science funding. I've done many different roles. There are many different ways in which you can enact change, and a startup is one of the tools for that. It's not the only one. And we want to build when we have high conviction. And it's one way to do it, but I think even if one then builds and then pivots afterwards, I think it's really good to start. And that means that a startup may not be the best first step to building a startup. It may be the best first step is being in the place which exposes you to really see and understand lots of problems deeply. Consulting is a great example of that in terms of that ability. And then, a lot of people go out from these companies to build great things. It may be deeply getting entrenched in the really low level bits of the technology. Surface level understanding of AI is everywhere, and it does look great things. Real envelope pushing happens at the minutiae. And so I guess my advice is you have all the time in the world to build something, and you can do it at any time in your life. Do the things that help you build conviction beforehand.
Okay. Good answer. Now the next one is a bit of a fun question we ask everybody is, in a nutshell, how do you build a great AI agent?
Know what it is you want to do and do just that. With an AI agent, context is a very important resource, as is tooling. If you boil the ocean and try and do everything, it's probably going to be good at nothing. Build an agent for a specific process. There you go.
Like it, very succinct. Look, Odhran, it's been fantastic today. Really appreciate you taking time out, your busy schedule, to join us and share all your learnings and your journey and what Magentic are doing, the fantastic work you're doing there. It's clear that it's going to be incredibly successful. I think I hope we get to speak again soon, and look, really appreciate you taking time to come.
No, it's my pleasure.
So to the folks listening, we hope this has been useful and helps you think about where agentic AI can add value to you or your business. If you're currently considering or experimenting with AI, we hope the stories and lessons shared today by Odhran will help you in that journey. Thank you for listening, and if you enjoyed today, remember, like and subscribe so we don't miss our next episode or future guests. I'll see you next time.